All right, good evening. It's 8 o'clock and time for class. This is Unity Live training, and we're going to be doing part 2 of Hat Trick, the Fun Catch game, which we started last week, and we got most of the basics down, and now we're going to finish the game, and we're also going to look at a sneak preview of Unity's uGUI. We're using three, good God. We're using 4.6 beta today. Not a usual thing for us to use beta software, but we wanted to have people to see a quick sneak peek of Unity's uGUI. My name is Adam Buckner, and I'm going to be doing today's session. I used to be doing the live training sessions for the last couple of years when we were doing it in closed rooms on Adobe Connect, and now here we are broadcasting super wide and live on Twitch. So glad to be here, glad you're here. So what are we going to do today? Let's go ahead and jump in. We've got a couple of stretch goals today. We're going to definitely finish this game, but there's some spit and polish that would be nice to add on top if we can get to it, primarily uGUI. I'm going to be trying to watch the chat, which is over here on my second computer. And I know there's a little bit of a lag, but I'll try to get to you. If we can keep the conversation focused on what we're doing today. If you've got a question about something that I'm doing and you don't understand it, please throw it in the chat channel, and then I will go ahead and answer it as quickly as possible. If you're inspired on how to do something like turn this catch game into an MMO for mobile, why don't we hold off on that and we can talk about that in Q&A at the end. So let's go ahead and take a look at what we've done. This is we've got a single main scene. That's our scenes folder, and there's our main scene. And the main scene is where we ended up at the end of last week, where we've got our camera. We have our hat object. Let me just move into scene view so we can see that. So there's our camera, there's our hat object, and that's made up of two sprites, a front and a back, and that's so that the ball can go ahead and land in between them. We have our sky background object, our holder for our ground object, and we've got three tiles of our. Let's move into tile mode there. So we have our 3 tiles here of our grass. And then we've got our bowling ball, which is a prefab. We will delete that when we get into the next step, because we were just using that to make our prefab. And then we also have a destroyer around the outside, and that's an edge collider. So if any of the objects fall out of the game and hits that, then we can go ahead and destroy that object. And when we're looking at our assets in our project view, remember, we've got our project view for all of our assets. This is the hierarchy, which talks about all the game objects in the scene, and then the inspector, which is what we're going to be looking at for the details of the game object in the hierarchy that we're inspecting or in the project. So we've got our scene. We've got a physics material 2D for our bowling ball. This is the bowling ball prefab that we made at the end of last time's session. Then we've got 2 scripts, which we'll go ahead and take a look at: the destroy on contact and the hat controller. And then finally, we have our sprites. I'm not sure we're going to get to the bomb today, but when we have the assets up on the asset store, you'll be able to take a look at the done folder and go ahead and play with that bomb. Whoops! Well, I've lost the video feed here on mine, but I hope it's going well for you. It looks like I've got full 5-bar bandwidth going out, so you guys should be good. Cool. Oh yes, the splash screen. Oh, the splash screen is still up. But was that useful? Sorry. Yeah, I mean, I'm not seeing it. I'm seeing it on mine, and I'm not seeing it on the video. We may have a stutter, so let me go ahead and redo this. Let me go ahead and push. We should push these guys again. I've undone that and redone that. Now let me know if you've seen the game, because I was seeing the game on my. You should have been fed, but we may have had a stutter. I'm waiting for the 30-second lag to come through on mine. So someone with a thumbs up if you're seeing the screen. That would be cool. And I'm going to wait there. I'm seeing it at my end. There you go. Not sure what that was. Funny little glitch there. This is my second. I will admit it's also my second time with this software with Twitch. So let's start from the beginning. So we're looking at the game that we finished at the end of last week. We have a main scene, so we're looking at the project view where all of our assets are. There's the scenes folder with our main scene, and we have physics material with the bowling ball. That's going to be the physics material for our bowling ball. We have our prefabs. We've got a prefab of the bowling ball that we made at the end of last session. 2 scripts, the destroy on contact and the hat controller, and then our sprites, which we're using to build our game, including the front and back of the hat. In the scene view, we have our main camera. We have the hat object, front and back, and if we turn that off, we can see how that front of the hat is going to, that front of the hat will be hiding the bowling ball because it'll come between the front and the back of the hat. We have our sky background, and then we've got a game object holding our grass, and so there are our 3 grass sprites. And then we have our bowling ball, instantiated bowling ball prefab, which we will delete when we get into the game. And there's our destroyer. That's just a simple edge collider that's surrounding our game, and that has the destroy on contact strip. So if any of the objects fall out of the game, it'll touch that collider and be destroyed. Okay, so we're at this game, so let's go ahead and take a look at what happens when we play. Well, when we play, the ball drops from the top, and we can catch it in the hat. The hat, let me go zoom in on the hat just to remind us where we are. We give a collider around the outside, and that's a proper physics 2D collision collider, and that's what the hat will be bouncing against. And then underneath at the bottom here, we have a second edge collider with the destroy on contact script, which destroys the bowling ball when it comes in. So no, the previous sessions. The previous sessions are best found on our the archive section of our website, which I can point to you when we get into Q&A. But essentially, if you go to the Learn section and then look for the live training archives, you can find last week's session. So we have everything set up to collect these objects falling from the sky. But what we need is something to spawn new objects, because what we have when we're done, what we have going on here is we've got this prefab that we've just set here, and we don't want that during the game. We want an object that can spawn the balls, that spawn our bowling balls, and so they drop into the game from above. So let's go ahead and create a spawning script. And so we need a script that spawns our collectibles, but it also needs to keep track of time and other aspects of the game. So I'm going to create a generic game controller that will do all of this for us. So let's create another new game object, and we'll put that in the hierarchy. And let's change that game object's name to game controller. And then on that game controller, let's add a new script. And now there's several different ways we can do this, but I'm going to use the add component button and go ahead and say new script. And let's call this script game controller as well. C# script. So we're going to be writing in C# today. And this goes ahead and it dumps. This goes ahead and dumps that game controller script right there on the root level of our project. So let's go ahead and file that away into our scripts folder, and then double-click it to edit it in MonoDevelop. So we have a new script here in MonoDevelop. It's our game controller, and we need to. And is that big enough for you guys to see? I assume so. I've zoomed in. So what's the core of this particular script? The core of this particular script is spawning. We want to spawn these bowling balls, and they need to come from anywhere along the top of the screen. So the first thing we need to do is have an aid to find the top of the screen and find the width of the screen. And this is going to be very, very similar to the code we wrote last week for clamping the hat. So let's go ahead and remove all the sample code in our game controller. Just get rid of that. And then let's copy the camera and start from hat controller. So we'll go over this in a second. Let's just grab this and let's plop this down into our game controller script. So what we're doing is we're taking a public reference to a camera that we can make this reference in the inspector. Please make it bigger. Okay, we'll try one more set to bigger. Soon we're going to get a problem of seeing the whole script, but hopefully that's big enough. So we've got a public reference to the camera, and then we have a private float, which is the max width that we have of our game area. And then in start, because we only need to do this once, we have a little quick catch here that if we haven't assigned a particular camera, if we haven't assigned the camera that we want, this part of the script will go ahead and grab the main camera. So if our cam is null, then cam will be equal to the camera.main. So it'll go and find the main camera in our scene. And then what we're doing is we're finding the far upper right corner using the screen class. So there's screen width. We can ask how big the screen is, and we can ask how high it is and how wide it is. So we're going to ask for a vector 3, which is our upper corner, and that is going to be equal to a new vector 3 of screen width and screen height, and then we want that directly on the origin plane of the XY plane, so at 0 on the Z. Then we're going to take a vector 3, target width, and then we're going to use our camera, and we're going to use screen point to world point. We talk about this in episode 1, but I just want to quickly cover what we're doing, and then we are going to find the upper corner. So that gives us the upper corner. And then from the code for finding the hat, we take our hat width, and we use the renderer to get the bounds, the size of the hat, and we use its extents, which is always half the size of the bounds, along the x-axis, and we subtract that from max width. In our case, we want to drop balls. So what we want to do is we want to create a new public game object, and that is ball. And what we can do is take our hat width, and let's change this to ball width. And I want it to be changed in all of the appropriate places, so I'm going to use refactor rename, and let's just simply call this ball width. And we can see that it's changing down here as well. So we've now changed that to ball width, and we want to take not the renderer bounds.extents, because that'll look for the renderer on the game object that the script is attached to, and we find it from the ball. So the ball's renderer, ball.renderer.bounds.extents. Now, the next bit is that we need to spawn these balls, put them into, we need to put them into the scene. And this will be a coroutine. This will be a loop. And if you need to know more about, if you need to know about coroutines, go ahead and take a look at that. Look that up in the documentation. You know, for more information on coroutines, please see the information in the documentation. So we're not going to cover the details of coroutines at this point. So let's make one. We're going to write IEnumerator, and not IEnumerable, which sometimes people make a mistake when they're using code completion. IEnumerator, and let's call this spawn. This will be our spawn coroutine. And what we want to primarily do is we want to instantiate our ball. And if we remember, instantiate takes an object, a position, and a rotation. So let's put in something called spawn position and something else called spawn rotation. Only if I can spell rotation, please. All right, so there we've got our instantiate. So that's the core of what this spawn loop is going to do. It's going to instantiate balls at a spawn position with a spawn rotation in our scene. But what is this spawn position going to be? For ease of coding, let's take the game object that's going to be spawning it and put it somewhere in the scene that will help us with our coding, for ease of coding. So let's go ahead and take a look at that game controller. And I'm going to go to out of the sprite mode and into transform. And I'm going to reset this position here, so it's in the center of our game. And where do we want it? We want it up, out. Let's back out a little bit. Above the game, somewhere up here, because this is where we're going to drop those balls from. I'm a fan of big round numbers when you don't need them, so let's go ahead and make that an even number of 10. So it'll be right outside the viewport of the game. And that's where we'll go ahead and spawn from. So our that's the spawn position. That's our transform position for the spawn game object. So let's go back to our scripting, please. So that's back to our scripting. And we need to write our spawn position. And what's our spawn position? Our spawn position is going to be a vector 3, because it's a position in 3D space. Even though we're making a 2D game, the editor is still 3D. And we're going to be on that main plane with z equals 0, and we're using the xy plane for making our game. But we still need a vector 3 for our spawn position, and that's going to be spawn Let's just copy and paste that so we get it correctly. Spawn position is going to be equal to a new vector 3. And that vector 3 is going to be made up of an x, a y, and a z. So what are each one of these values? X, Y, and Z. I'm going to quickly separate these so we can look at them individually. X, Y, and Z. X, we want it to be a random range. We want X to be anywhere from the left side to the right side at the top of the screen. So we want a random range that is the width of the top of the screen. Now what we're going to write works because our game object is in the middle, and this is 0. And so we know that out here is our max width. So over here is our negative max width. So when we come back to our code, what we want to write is we want our X to be a random range from negative max width to positive. Ooh, learn to type max width. Oops, no semicolon, please. We're in the middle of this function. We need a comma. And what's our Y? Well, our Y is the position of the game object. So our Y is transform position Y. And Z, we want to stay on the plane. Now we could go either way. We could use transform position Z because it is at 0, or we could just simply say 0. So this is our game object's location and position on the x-axis plus a random range of minus our max width and our max width. It's our game object's location y, which is 10 units up, and it's 0, the origin point on the z-axis right there in the origin of the xy plane. So that gives us our spawn position. And what's our spawn rotation? Well, let's have a spawn rotation of nothing. And remember, a rotation is a quaternion. So that quaternion is going to be spawn rotation. And what is it going to be equal to? Let's just make this no rotation. Quaternion.identity. We can talk about any of these in Q&A if you have questions, or look them up in the documentation. Quaternion is a way of representing rotations, and identity essentially means no rotation. So now what we've done is we can instantiate our ball, that's our object, at a spawn position made up of an x, a y, and a z, at a spawn rotation of no rotation whatsoever. Now let's put this in a loop, because currently this isn't a loop. If we go ahead and, if we did this once, if we called spawn, even though it was a coroutine, it would simply run once and we'd be done. We'd get one ball. But we want to spawn as many balls as we can. So what we need to do is we need to put this into a loop. So let's go ahead and indent this code and then put it in a while loop. And we're going to make an infinite loop at this point. Let's just say while true. And this will go on forever. Close those brackets. If we ran this, saved this, and ran this now, we'd lock up the editor because it would stay inside this loop, spawning forever, and it would not even stop to render a frame. And we'd get a spinny beach ball or the little little sand timer on Windows, and we'd have to force quit the editor at this point. So let's not do this. And the way we stop this is we put in yield. We ask Unity to stop for a period of time. If we stop for even just one frame, then Unity can continue on in its game loop. So what we're going to do here is we're going to yield, and we're going to return a new wait for seconds. And what are we going to wait for? We're going to wait for another random range. Random.range. And in this case, this is hard-coded. I'm just going to hard-code in some numbers. If you want to have more versatility, you can make a public variable for this. But this random range is going to be from 1 second to 2 seconds. So we're going to wait between 1 and 2 seconds and then go back and do this loop again. Now we have to start it. Again, this is a function. Well, it's a, I mean, even though it's, it is a coroutine, but we have to call this coroutine. It doesn't, Unity will not call this by itself. It's not like start, it's not like awake or fixed update or update that Unity will call the code. We have to call the code ourselves. So let's do this when we start the game. First, we're getting our camera, then we get our max width, and then let's call start coroutine, and the coroutine that we want to start is spawn. Now, in this exact code, the spawn loop would start right away. So let's give our players just a small moment to breathe. So when they start the game, the game's gonna start. They need to get their hands on the controls. They need to get ready for it. So let's give them one quick little break here, and let's actually do another yield right at the top. New yield, return new, wait for seconds. And what do we want to wait for? Let's just wait for 2 seconds. And we wait for 2 seconds on the top, and then we start our spawn loop. So let's save this, and let's come back to Unity, and let's hope we don't have an error. Okay, what have I done? Oh, yeah, I forgot my second parenthesis there. There we go. Nice clean code. So let's save. We need to hook up our game controller. So we need to assign the camera if we want to. We only have one camera in our scene, so I'm going to let that be found automatically by the code. And then let's hook up our ball, and that is the prefab. So we go into our prefabs folder, and we grab the bowling ball, and we're going to put that into the ball. Let's delete the instance that we used for creating our prefab. That's gone. Now let's save this, and let's go ahead and play. Ooh. And there they fall from outside the game. And they're randomly arriving from anywhere, from anywhere along the top of the game edge. Oops, I didn't get that one. And this is infinite. This is gonna, well, go on forever until we run out of power. I fall asleep. We get bored. Not that much of a fun game at that point because it's never ending. So let's go ahead and find a way to limit our game loop. Let's contain that loop. We need to do that back in code, so let's go back to monodevelop. And we need to create a new public float variable for us so we can assign it. So it's a public float, and it's going to be time left. For this particular game, I mean, you could make this anyway. You know, how long does it take to capture 10 balls? Whatever you want to do to limit the game. In this case, let's see how many balls you can capture in the time allowed. So let's create a public float called time left. And then let's change our spawn coroutine from while true, which is infinite, to while time left is greater than 0. So we will assign a time to this. We will let time tick down, and when we reach 0, we'll stop spawning our balls. So now we need to find a way to decrement this time. Whatever we set it to, time left, it would be 10, and it would stay 10 unless we can decrement it. And what I want to do is put this into, oddly enough, fixed update. But boss, fixed updates for physics. Well, it is, but also fixed update comes at a regular period of time, and also fixed update on a fast machine is not going to happen every frame. We need to count down time, but we don't need to be counting down time, say, in an update loop where every frame, 30 frames a second faster, we're counting down an incrementally small amount of time. On the other hand, we could make a coroutine out of it, but we couldn't really put it in spawn. Spawn only ticks over every 2 to 3 seconds, so we'd have very uneven update. So here, if we put it in fixed update, we have regular updating of the decrement. It isn't too taxing on our system. Not that this game is going to be taxing at all. It's so small on pretty much any system. But it's sort of a good place to put something that doesn't need to be updated every frame, and we don't really want to write our own coroutine for it. And so what we want to put in fixed update is simply time left minus equals time dot delta time. So what we're saying is every time we hit fixed update, remove from time left the amount of time that has passed since the last time we were here in this update. And the nice thing about time.delta time is that it's smart. If it's in update, it gives us the current, which will probably change every frame, the time it took since the last update, since the last time the frame came around. In fixed update, it gives us fixed delta time, even without having to ask for it. So let's save this, come back to Unity. And let's go ahead and hit play. So the balls are going to fall from the ceiling after our 2-second wait. Hello? What have I done wrong? I've done something terribly wrong. Let's take a look. We haven't set it up. Good, great gravy. So yes, of course, we've read 0, so we don't do anything. So let's go to our game controller. Select the game controller and give time left of, let's say, 10 seconds to play the game. So we're going to play the game for about 10 seconds. So let's hit save and play. And the balls are now going to drop from the top until time left is less than 0. So let's go ahead and hit save and hit play again. And there we go. So we've got balls dropping from the ceiling. But this is not going to go on forever. 1 or 2 more, and that'll be about it. Now it's stopped because time left, and we can see that up here. Our time left is now in a negative number. So, good. We've limited our time. How many balls can you catch in 10 seconds? Or however many seconds you want it to be. But we should display this. We need to be able to see this somehow. And this is where we get into our uGUI preview. So we need to create some way of seeing this score. And so let's do this in new uGUI. Realize that I'm using version 4.6 beta. This hasn't been released to the public yet. This is a sneak preview of a work in progress. There is a good chance that some of these things may change a little bit, but this is the basic way that we're going with our new UI at this point. And we're going to make some very, very simple material here. I'm not going to be doing anything flashy, anything animated, anything too over the top. But like I said, quick sneak preview. So let's, from the Create menu, we're going to create a new text object. And what this does is it creates a new it's detecting to see whether there's a canvas there already, and then it creates a new text object that is a child of the canvas. All uGUI elements need to be children of a canvas. And the scale of the canvas, let's take a look at this. Let's take that canvas and hit the F key for frame selected. It's very big. And part of this has to do with the way that you want things to look good on screen and pixel perfect, which we won't go into details with right now. But it is worth noting that the canvas is very large. It's scaled automatically to the size of our game. And it's much larger than our game view. So if we come back and we look at the sky, we're going to see that is relatively small way down there. And that's perfectly normal. It's just the way that these are rendering on the different cameras. So we've got our text object. No, this is not on GUI. This is on uGUI. No, it's not on uGUI. It is just uGUI, and it's the sprite-based UI. Also, we should note that the canvas is automatically put on a UI layer, and so are all of the children. So there we are on the UI layer as well, and it's being rendered on its own internal camera as far as I'm aware. When we're looking at the canvas and the text, we should also be aware of the rect transform. This is not a normal transform that you would get from a game object. It has its own special rect transform that does all sorts of copious and wonderful things that you need for a UI, including anchoring and aligning the rectangle that you're going to put your UI into. So let's go ahead and build this. Let's change this text, and let's call it timer. Oops. So that's our timer. And, well, frankly, no, we'll change the typeface later. Let me go ahead and just, let's do our anchors and alignments first. When we want to anchor and align something, we can click on the anchor and alignment button, and there are a bunch of presets. I want to take this piece of text and align it in the upper left-hand corner. And if we hold down the Shift key, it will also set the pivot. And if we hold down the Alt key, it will also set the actual position. So we could align it to that corner by simply clicking on the upper right, and we can see that the anchors are now on the upper right. But if I want to actually move it up there and align it to it, move the pivot, I can hold down the Shift and Option key, and boop, it just pops up to the corner. So that's automatically aligned based on the presets. And let's go ahead and change the text. And the text is going to be time left, colon, and then we can use clear returns. We don't need alt returns. We can use just simple clear returns there. And then I'm going to put in 0, 0. So time left is 0, 0, or we can say question mark, so we know that we haven't assigned anything to this. Now, Arial is the font, and I think that's actually kind of boring. So let's create a new folder, and let's call that new folder Typefaces. And then on our desktop, we will find our typefaces. And I have something called Shark Fun, which is a free font. And then we import those typefaces, those fonts, exactly the same way that we do all of our other assets. You can simply drag it into the project and Unity will import it. And now on our timer, if I want to change that font, it's simply drag that new font in. Bonk! And we now have a different typeface there. Let's make it a little bigger, say 36. And then let's center that and make that align to the top. So we've got top center there. I want to give it some margin, so let's go ahead and drag it out. So we can be dragging it off this anchor. So now when we move this sprite, it's going to be based onto that anchor. So, or we can type the numbers into the position X and, oops, that's -10, -10, and -10 for X and Y to give us some extra space between the text that we have and the edge of the game. And we're not quite seeing all of our text, so let's go ahead and drag that down until the, because it'll get masked by the box. So if we want to, we can make that just an even 85. Some of the text effects, let me change, we can change color, make it red or green, or make it some nice blue. I had some nice blue up there. I think it was 0, 100, and 255 was something like that. And then the alpha channel as well. Let's go ahead and make that 255. You can add shadow to it, none, shadow, or outline. A little bit hard to see probably with at your end with the compression because it's relatively subtle, but I'll leave the shadow on. So now we have this text object, and we need to update this from the game. We need to script to this object. So it's our game controller that's keeping track of things. So we need to find a way to keeping track of the time. So we need to find a way to send that time information to this text object. So let's go back to MonoDevelop, and we're going to need a reference to this text object, and it's type as text. We can see that type as text. So what do we say? A public text. Now this is going to fail. Where's text? My code completion is not giving me text. It's because we need a new namespace. We are using Unity Engine, but we also, in this case, we need to be using Unity engine dot UI. So this all resides in a different namespace. So we need to make sure that we have that Unity engine dot UI to be able to find text. So what are we going to call this type of text? Let's call it timer text. And in fixed update, where we've said our time left value is decremented by delta time, and we need to take our timer text and make it equal to time left colon, and then since we're coding, we need that \n for new line, and then we close our quotes, and then we want to add mathf round to int. And remember, if you don't know about mathf, definitely look that up in the documentation. Lots of very, very useful math functions. In this case, we're going to round a float to an int, and that float is going to be time left. So our timer text is going to be set to the string value of time left and a new line, and then the time left. We don't have to convert this to a string. We could if we wanted to, dot to string. But Unity, if it sees a numerical value being added to a string, the destination is a string field, makes the assumption that you want to convert that to a string. So let's save this, come back to Unity, and now our game controller, once we compile, oh, what did I do wrong? Oh, duh, sorry. Timer text. I'm Russian today. Sorry about that. Timer text.text. We're not sending it to the text. We have to find the text property. My mistake there, Russian a little bit. So the time left is going to go to the timer's text property. So we have to address that as timer text.text is equal to our time left. And our error should go away. There we go. And now if we come back to the game, if we hit save, we hit play. Oh, crackers, I am Russian today, aren't I? We have to sign our timer text there. Sorry, I've been rushing. Long day today. So let's go ahead and populate our timer text. Now that we've populated all of our proper references, let's go ahead and stop having red stuff in our console. So there we go. Now we've got our timer counting down, rounded. If you want to be clever, you could get the percentages. But what's oh no, we're in negative time. So how do we stop that? We don't want to see that negative time countdown. We want to stop it at 0 and have it stay at 0. So let's come back to our code, and in fixed update, we want to say, after we decrement our code, if time left is less than 0, time left is equal to 0. Just a simple little trap. Otherwise, we go into that negative number. And so what we want to do is always make sure that we see that going from the top to the bottom. Now, one of the problems that I also see here is we're starting off with our double digit here, with our question marks. And when we start the game, we see the question mark until that very first frame. We could copy this line and put that into start. That would work. But we now have two identical lines of code. That's kind of ugly. So why don't we create a new function? Void update text. And that update text will have this line. And then what we do here is, instead of calling this line multiple times, simply call update text. So let's go ahead and cut back to Unity, and hopefully we will have no more errors, no more bonehead errors from me, and it works. So let's go ahead and hit save, and let's go ahead and hit play. And we can see on that very first frame, this is now set to 10, and then we have a nice countdown. And when we reach 0, it stays at 0. So now we need to count some points. We need to figure out how many of these points that we count. So we want to select our hat object, because our hat object is the thing that's catching those balls. And let's create a very simple new script on the hat object called score. Let's go ahead and make the game object first. Let's go ahead and make I was going to make this the score script. We will use that, but let's go ahead and also make the text object while we're here. So let's go ahead and make a new text object. Then you can see how that's automatically being put underneath the canvas. And then let's call this one score. Or we could call these score text if you want to. So we can tell what these are. Score text, timer text. Whatever makes you feel comfortable. And let's put this in the other corner. So again, looking at our scene, let's take, there's our new text object generically just sort of sitting there in the middle, and clicking on the presets button and holding down the shift and the alt key, shove it up there in the corner. We can now see it's anchored and positioned there in the corner. Pulling it down just a little bit off the edge. There's a snapping. That's snapping to the same top point. So that's going to snap to -10. But we also want an even 10 on the position X. Let's change our new text to score, and then 0. And again, clean returns inside that text field. You don't need alt return or anything magic. You can just go ahead and type or paste any sort of text you want in there. New typeface. Let's clean up that typeface, get rid of Arial, get our shark font, and let's get that up to 36. Again, we are clipped, so let's pull that down, give it some space, and then let's center it. Again, top, center, and center, but it's wider than we need it to be. So let's go ahead, because we want that margin to be similar, it's to be about the same, so let's bring that down as tight as it can be. About 80 looks good. Me and my straight numbers, let's just make that 80. Does that work? Yeah, 80 does. So let's do 80. So we've got our score, and we've got our time left. Let's go ahead and match that color as well, which was a color of blue. I think that was no red. Oops, no red, please. 100 on this green, and 255 and 255. Get full alpha. And I believe we've got shadow on that as well. Yeah, we do. So there we've got matching score. So let's take a look at our hat now with our hat script, and let's go ahead and edit that. Now this is going to be an incredibly simple script. We are going to be needing that Unity engine.ui, so using Unity engine.ui. Because this is going to write to the text, and it's going to be the same thing that we did essentially in the last script, except with the score. So we want a public text object, which we now have because of our Unity engine.ui, and our score text. And then we also want a public int for our ball value, because we need to give it something to increment. And then in private, int our current score. So in start, we want to say our score is equal to 0. And again, we have that same issue where we're doing our score. We want to say our score text is going to dot text. Remember the dot text this time, guys. Score text dot text is going to be equal to our score and then our return score. Let's get a colon in there. \n plus our score, which is already an int. But we're going to run into that same issue, aren't we? So why don't we cut to the chase? We don't need update for this. And create that void update score. Because we're going to have to set this when those balls come in, right? Does that make sense? So we want to update our score. So how do we find out when a ball has entered the hat? Well, take a look at our hat. Our hat has the edge collider that's set as a trigger. And that trigger currently is running our destroy on contact script. Our destroy on contact script is simply saying void on trigger enter 2D. And remember the 2D function there. Then we destroy the collider 2D that bumps into it. So we need to do something similar. We want to say void on trigger enter 2D. And remember the 2D because that's the difference between the 2D physics engine and the 3D physics engine. Ooh, learn to spell. Don't need that extra J. Anybody want a J? Going cheap. So when we get that on trigger enter 2D, we want our score to be incremented by our ball value. And again, as soon as we've updated our score, what do we want to do? We want to update our score. So let's save that and return to Unity. Nope, let's not do that. Jumping ahead there. So let's go ahead and populate our score text. And let's give it a ball value. What's our ball value? Let's just give it a ball value of 1. Let's give it a value of 1. So we've got our score text there. We've associated our score text with our score script, and our ball value is 1. So let's save that. Clear out that embarrassing red bit. Now we can hit play. And there's our score. And as the balls drop, boom, we count up. 6. Not bad. So this is the basic game. We've done the most basic game. I've got 2 stretch goals here that I want to try. We've got 8 minutes. We're probably going to run over a little bit, and then I'll give you guys a quick poll and see how we're doing. So let's wrap up this basic game, because we can now count score, and we've got time left, and we have the very basic games. But let's add a game over label and a restart button. And again, we'll be doing this in uGUI. So let's take that create, and let's create a new text game object, and let's call this one game over text. Double click or hit the F key, and we can focus in on this new text object. Let's go ahead and quickly blast through this and give it a text of game over exclamation point. And new typeface, get rid of that Arial, give it something a little bit more classy, up to what did we decide, 36? A little bit bigger. And then let's go ahead and center that in the box and put that in the center. And let's go ahead and see we've got where is it? Overflow. Let's move from wrap and truncate to overflow, and we will now spill out over the edge of the box for our label here. And I'll also show you how to go ahead and adjust that to fit. But first of all, let's set our overflow so that we aren't being masked by that rect. And let's change the color. Let's change the color to red, just because it's nice red game over there. And then let's center it. So there's our presets, anchor presets, and I'm going to hold down again the Shift and the Alt key and set it to the center. Frame selected, and there we can see it there is in the center of our game. We can reposition the rect around it. If we hold down the Shift key, it stays proportional. If we hold down the Alt key, it moves from the center. Hold them both down, it's proportional, and it moves from the center. Hey, magic. So let's just make that rect bigger. It's not necessary because we're overflowing, but you know, we'll do that for sake. And then also I want the restart button in there somewhere. So let's go ahead and lift that up. Oops, that's just off center by, I think that's is that an E at the end? Yeah, that's float. That's the typical float errors there. So let's lift that up. I don't know, some even number, let's say 50. And now we want our restart button. And nice to see how we hook up a button, so I want to go ahead and show you that. So let's go ahead and create a button. And let's call this button restart button. And again, we can see that it's similar to the text label that we have. We've got our rect transform and our UI renderer, and we've got an image, but we also have a button script on it, and we have a child. And that child is the child label. I'm not going to go into the details of the anchor, but notice how the anchor on these other objects, all four objects are together. They're saying we're anchoring on that point. But if we look at the label, we can see that the anchors are on all four corners, and that's because we want the label to actually stretch with that of the parent. So when we anchor the corner, you can anchor the corners separately. Again, you'll see this more as just a preview. You'll see this more as we go on. But I just wanted you to note the stretching corner anchors. And that's the label for the button. So on the label, let's change button to simply restart. And again, change our typeface. And let's give us some size. And we're starting to poke over. So let's make sure our alignment, yeah, it's centered. And come back to our restart button. And here again, we can adjust the size. And hold down just the Option key so that we adjust that to fit. If we want that to be back in the center, we can pop that on. So there's our restart button. Now we need to script to this restart button. So let's go ahead and select the restart button itself. I'm going to get rid of that the preview window. Come on, preview window down, thank you. And we can add a new component, and that's going to be the new script. And that new script is going to be restart. So again, this dumps these into the root, so let's go ahead and file those away into our scripts folder and then open restart for editing. So here's our restart button. This is the script for it. This is going to be another very, very simple button. We're going to make a very simple function to hook up that button. So let's remove all of the sample code. And let's write public. Now this is important. This function needs to be a public function. When we're writing C# and we just simply write void, it's automatically private. It's automatically a private function. We need this to be a public function. So we want to write public void. And then let's create a function called restart game. And our public function is going to simply say to the application, we want to load a level. And what level do we want to load? The already loaded level. So this will simply reload the exact same level that we already have. It'll simply reload the level. So we're saying application load level, the currently loaded level. So it'll restart it. So let's save that and come back to our game. And if we look at the restart button, we have this on click. This is an event handler. You can create additional event handlers. Is it event? Oh, it's under event. Sorry. Add component, events. And you can create an event trigger, which is the same that we have here. This one only does on click and it's automatic. But this one you can use on pointer enter, on pointer exit, pointer down, pointer up, pointer click, drag, drop. All of these things can be activated through the event trigger. But there is a default one, I'm going to remove that, on the button itself, and that is simply, was the button clicked? Did the pointer come down and go back up again on this same button? So what we can do is call any function on any script that's public from here. So let's drag our restart button as the game object. So this is the game object. And so then we're looking at all of the possible components on this game object, including our restart script, and then all of the possible functions we can call, and there is restart game. So when this button is clicked, the game is restarted. So let's save this. Let's go ahead and hit play. And we're only testing the button only. We're not actually going to, because this is going to be right here in the middle of the game, and we don't want to do that. So let's hit restart, and we can see that's restarting. And it's automatically got a color for hover and another color for click, and it restarts the game. So we can simply hook up a button to restart the game at that point. Now, we've reached 9 o'clock. That is technically the hour. I have a couple more minutes, and we can go ahead and hook up, hook this into the UI. Yes, you can send simple parameters to the event handlers, and I've forgotten the limit. It's something like bool and int and float and object, and I believe it's only one at this point. But don't quote me on that, and this is beta software, and we may see changes before it's released. So I would like to continue on and try to punch in one of my stretch goals, even though we are at the hour. And let's see where we get to, because we have our restart button. But I'd like to sort of hook that in so that it actually makes sense, this restart button. We've seen how it works. You've seen how that you can apply a function to a button. But let's carry on over for a couple more minutes and see how far we can get. So let's hook this UI into the gameplay. And the first thing we want to do is deactivate our restart button and deactivate our game over text, because we certainly don't want that at the start of the game. When the game starts, we just want that to be clear. So let's open our game controller, because remember, it's our game controller that is going to be, well, heck, controlling our game. This is where I hope it doesn't get too small, guys. Let me know. We need to see a bunch more of this code. If you can't read it, let me know. And so let's add two references here. Public game object, and that's going to be our game over text. And public game object restart button. And in spawn, after the loop is over, when we've fallen out of the loop, when time left is no longer greater than 0, we fall out of the bottom of that while loop, and then we want to do another yield, return, new, wait for seconds. We want to wait for a couple of seconds. The game's over, but let's not just slam our players too hard. Let's wait for a couple seconds. We wait for 2 seconds, and then what we do is we turn on our game over text. Our game over text. And what do we want to do with that? We want to set active true. And then give it some space, yield, return, new, wait for seconds. Let's just do another 2 seconds just for, if you were to do this, you could adjust these numbers to your heart's content. You can make variables for these and you can change them in the inspector. Let's then make our restart button set active true. So let's go back to Unity and not do what I did the last 2 times and hook up our references before we try to play them. So there's our game over text and there's our restart button. Save that and we hit play. Now, catch as many balls as we can in 10 seconds. And then, whoa, missed that one. Game over. Restart. And then we can restart the game. So, well, that's the basic game. It's just over an hour. That's actually the reason it's counting down before the balls come down. It's actually, let me just show you that in game view. Let me see if we're going to need to leave the game view open somewhere because it's going to want, Unity will want to play it. So let's just hide the game view way down there. You need to realize that this text is dynamic. So, ignore the text because you see we're anchored and it's trying to fit it all inside this tiny thing because we've asked it to be anchored in the corners, but we haven't asked it to shrink. So we're dynamically compressing the score down there. But the reason is that I want to look at, where am I looking at? Let's back out. What's happening here is, remember, our game controller, it's up here. And our camera is here. So when we play, actually, I'm going to just take that off, pause for a second, and then there we go. So arguably, the problem we have here is that it's going to take, as gravity is pulling this physical object, a few frames before it enters. We could be clever. I just threw that game controller object at the top. We could try to be clever and fit it so it is one ball's width above the main camera, somewhere in there. So there'd be less of a delay. I mean, because I was more interested in the logistics of it. So this would, once you do that, the balls should spawn closer to the top of the, but they also don't have quite the same velocity. So let's push that back out here. Bop. And note that our UI has automatically adjusted. If we were to suddenly go to phone, boop, automatically still there in the corners. So we're now on a phone resolution. Haven't changed the UI at all. And we can see now there's a little bit more warning. They start to fall like drops. So, I mean, if you were to play this game, you could give it, write this game, and you could give it more more velocity when they're spawned. You could take a reference to that, to the balls, and then give them some velocity when they start. So they come shooting down a little bit faster rather than just letting them drop naturally under gravity. Well, I think I'm done. There's a couple more fun things we could do, but we're trying to keep these to an hour. Thanks for coming. I appreciate all of you watching this. Go ahead and make comments if you want. We have posts on the forum. Go to the teaching section of the forum, and there's a thread in the stickies on live training. Don't forget to thank Unity Technologies for making this all possible. And you can follow us at Unity2D, at Mike Geig, and at Will Goldstone, and me the one guy who doesn't use his name at the Ant Ranch. So go ahead and follow us on Twitter. You can ask us questions on Twitter. You can also follow us on the forum if you want. And like I said, go to the teaching section and look in the stickies for live training if you want to go ahead and leave comments and feedback. And definitely take a look at the Learn section and the documentation if there's anything that you don't understand. Thanks for coming.